with this, we are going to be talking about quadratic equations and specifically how to solve quadratic equations. And so we've talked about one way in which we can do that, but we're going to be talking about more ways today. So when we're talking about quadratic equations, remember, they're in the form of ax squared plus bx plus c equals 0. So really, if we're talking about a quadratic, that just means our highest exponent is a 2, right? So that x squared is what makes it a quadratic. If it was like an x cube, you'll talk about those in 1050, and those are cubics. And so there's different types of equations, but we're focusing on the ones where the highest exponent is x squared on this. And so we talked about one way already that we could solve these quadratic equations. We talked about if we factored them, right, we could use that thing called the zero product property, where we set it equal to 0 and then factor it and solve it, right? So maybe for a little example over here, just to remind you, so this is what we're going to be building on today. So if you had a quadratic equation that says this, all right, and so remember how you have to get everything over to one side, put it equal to 0, and then you're able to try and factor this, right? And there's a lot of different ways that you could do the factoring of this, but when you go through and do the factoring, you get, let's see, it would end up factoring to be something like this, right? So we've talked about all those different ways. You could do synthetic factoring, you could do the guess and check method, you could do the, box method, factor by grouping. So however you get there is totally up to you, but at some point you'll get to that factoring. And then after you factor it, you set each of those parts equal to 0 to get your solutions, right? So here we get x equals -1/2, and here we get x equals -3. So we came up with two solutions, and remember when we talked about this before, we are expecting to get two solutions because our highest exponent is a 2. Right? And that's kind of telling us that. If our highest exponent's a 3, we'd expect 3 solutions. If it was 4, 4 solutions, and so on. Okay? So that's that zero product property. So kind of a little review over that. That's one way that you can solve these, but we came across quadratics that couldn't be factored. So today we're basically going to be talking about, well, what do we do if we can't factor them, right? So these are the different things that we're going to talk about today. So we're going to talk about the square root property. Is another way that we could solve these. We're also going to be talking about something called completing the square. I'm going to talk about the quadratic formula. And another way that we're not going to talk about today, but it's going to come up later in the unit, in our module, is that you can also solve quadratics by graphing the parabola. All right, so any quadratic is going to have this shape, same shape, and we call that shape a parabola. So we'll talk about that later. So we're going to mostly be focusing on these three things in here today. But I'm still going to kind of show you some things with graphing because I want to make sure that you are making the connections that you need to. All right, so, and then specifically later in the module, we'll get into more specifics about those. Okay. So if something can't be factored, or even if it can be factored, we can solve it in these other ways, right? So sometimes people are like, oh, I just suck at factoring and I really don't like it. And so sometimes they'll pick one of these other ways to solve a quadratic rather than factoring it, even though, factoring might be the fastest way as long as you're good at factoring, right? But if you're not, all is not lost. You have other ways that you can do this. Okay, so let's first start talking about this square root property, right? And so basically, the square root property, remember, whenever there's a way to do something in math, there's always a way to undo it. Right? So if I have something like this that says like 4 minus 3x all squared, right, equals 16. And we're asked to solve it, right? The fastest way to go about this, right, would be looking at this saying, well, how could I get rid of that square? Well, to undo squaring something, I'd want to take the square root of both sides. Okay? But we've got to be really careful with this because, and I'm going to do a little thing out to the side here just to make sure it's clear. If I had something like x squared equals 4, because this one's a little bit easier to think about, right? It's really saying what number, if I square it, equals 4? Well, if I use the square root property on that, right, sometimes students say, oh, x equals 2 is the answer, right? But is that the only answer? What do you guys think from the videos and stuff you watched?
It could also be negative 2.
Yeah, it can also be negative 2, and that's what some people forget, right? Because remember, you're thinking, what number squared equals 4? Well, you could have 2, right? 2 times 2 is 4, or if you have negative 2, it has to be inside the parentheses like that, right? Negative 2 times negative 2 also equals 4. So that's why we end up with these two answers when we're doing this, okay? So it's really important when we are doing this square root property that after we take the square root of both sides, right, this square root and square undo each other, and so then we're just left with the 4 minus 3x, and it doesn't just equal 4, right? Square root of 16, we need to put plus or minus 4 to help us remember that we have two different things that is happening there, right? And then we can go ahead and just solve it for x from here. And maybe it would be easier, to think about this. You could keep the plus or minus in there, or you could write it out as two separate equations. I'm just going to show it as two separate equations. Just hopefully it'll make a little bit more sense. So we're saying that 4 minus 3x equals positive 4, and 4 minus 3x equals negative 4. And then we're solving each of those for x. All right, so let's subtract the 4 over. So here I get negative 3x equals 0. If I divide by negative 3, 0 divided by anything is still 0, right? And then we need to do the other side. So subtract 4 over. Get negative 3x equals negative 8. And I divide by negative 3, get x equals positive 8/3. Okay, so I still end up with two answers here. And remember, whenever it's telling you to solve something, you can always check the answer by plugging that back in place of x into the original equation. So, always think about trying to do that check if you're ever, worried, did I do that right? So what questions can I clarify on that one? Does it make sense to everybody why we're going to end up with these two answers. Why we do that plus or minus 4 in this case. Okay, so that's the square root property. So if you have something squared on one side, you can square root both sides to try and solve it. So, but sometimes we have something that we want to use the square root property on, but it's not written in such a way that we can use that square root property. And so that's where this completing the square comes in, that we're going to talk about next here. All right, so if we have something like this, let's do, so next way that we can look at solve this is completing the square. And so I want to talk about, how we are going to do this. And I'm going to use some visual representations too on this first example, just to see if that might help people understand a little bit better about what we're doing on this. And remember, so we're trying to get it into that form that we had above, where if we could square root both sides, right, to figure out what x is. So let's look at this example. So let's say that it asks you to solve by completing the square. All right, and then it gives you something like this. M squared plus 10m plus 14 equals 5. Okay, so the first thing that you're going to do when you're completing the square is we're going to move that constant term that's on the left side over to the right side. All right, so I'm going to start by subtracting that 14 over. Okay, and when I do that, I have m squared plus 10m. I'm going to leave a little blank here, and you'll see why in just a second, equals negative 9. Okay. Then I'm going to show you kind of, like I said, pictorially as well as, with the equation, what is happening here. So I'm going to draw a little square out here because it's called completing the square, but sometimes people are like, why is it called that? That seems so weird to me. All right. And so remember when we did the box method, I'm going to just do a little thing up here. And if I had like, x plus 2 times x minus 5, we could multiply those together to figure out what our answer would be, right? So we do x times x is x squared. We get 2x there. We get, and maybe it's better to put that negative there, negative 5x, and then negative 10. Right? So we're just kind of multiplying those around. Well, on this one, it's like we're undoing it, kind of in the way that we were doing with factoring it. So our m squared, right, that we have here in the beginning is going to go in that first box. Right? So we have that. Now this 10m is going to be broken up between the two. So let me see if I can try and draw this over here. All right, so this 10m is going to be split in half, right? And half of it's going to go here, and the other half is going to go here. All right, so I'm going to put 5m in both of these because 5m plus 5m gives me that 10m. Actually, I need to kind of move that a little bit. It's going to be in the way. Go like this. Okay, so that's where I'm putting those, right? Those are splitting in half. And then, so I'm thinking, okay, if I was, trying to think what the factorization of this would be so far, all right, well, what times what is m squared? Well, that's the m times m. So let Let me make sure everybody's with me here. All right, so m times m gives me the m squared. Remember, just like we did over here, to get that x squared, we did x times x. Well, now we're just undoing it. All right, if we have x squared in our box, then we know x times x gives us the x squared. So m times m goes there. And then I'm going to have a positive 5, right? Because m times, whoops, did I put, yeah. So I have the 5 times m gives me the 5m there. Okay, and this is also going to be plus 5. All right, m plus 5, or m times 5 gives me the 5m. And then the part that we're doing for completing the square is kind of figuring out, well, what would this box be? So if I did all this multiplication here, right, then I can see, all right, I'm doing the 5 times 5 is going to give me the number in this new box, which is going to be 25. Right? And so when I'm looking at this, right, so let's go back over here to the equation, and so you can kind of see what's happening equation-wise. All right, so when you're doing this, the equation, you're thinking, okay, what's half of my middle term? All right, well, if I do, 10, well, actually, let me do that in a different color. I use this color for those. So 10 divided by 2, right, half of it, and then squared is what I'm trying to do to figure out what goes in this blank that is here. Right? So it's kind of like we have a plus blank, and if I add something to one side, I have to add that same thing to the other side. And so half of the middle term, so 10 divided by 2 is 5. 5 squared is 25. So 25 goes in both of those blanks, right? And then on this, all right, if we keep going with this, let's kind of simplify things up here. The reason why we made this trinomial on the left-hand side into a perfect square trinomial so that it would factor to be, so let's look at the factoring of this. So let me just write this down again here so you can tell what we're doing. So if I factor this left side, all right, I'm thinking m and m, all right, and then that factors to be the plus 5 and plus 5. All right, so that's where in the picture, that's where I'm getting these from. All right, the m plus 5, the m plus 5. All right, and then equals negative 9 plus 25 is 16. And so on this, right, do you agree that this m plus 5 times m plus 5 could also be written as m plus 5 all squared equals 16? And so now we can say, all right, well, it's now in the same kind of form that we started off with in this square root property where we have one side that's squared, right? And so to undo that square, we're going to square root both sides. Right? And so that leaves me with m plus 5 on this side. And then on the other side, I end up with that plus or minus the square root of 16, right? Which is really that plus or minus 4. And then from there, I just need to, figure out what m is. Again, if it helps you to think about, remember there's two different equations we're dealing with here. M plus 5 equals positive 4 and m plus 5 equals negative 4. And then just go ahead and complete that, get m by itself. So m equals negative 1 and m equals negative 9 would be your two solutions on that. Okay. So hopefully it's kind of a little bit You know, but so when you're talking about completing the square, they always say take half of the middle term and square it. But a lot of times people are like, why am I doing that? Right? But you're trying to figure out what this would be, what this perfect square trinomial is going to be. Right? And so you can find that by completing the square. So that's kind of why I drew the picture. For some people it helps, other people maybe not so much. So it's just everybody's a little bit different, and I want to make sure I'm helping everybody the best I can on that. But what questions do you have there on that one about the process of completing the square, or any questions at all there? Hey, you're welcome, Amber. I'm glad that helped. All right, and I know there's a lot of you that have been using the box method with the factoring and stuff, and so I think that that's just a good tie-in for those of you that have been using that. It might, you know, help you a little bit more.
I went to the workshop on Saturday morning for help,
Uh-huh.
and I said the box method, and the lady was like, I don't know what that is.
Oh, really? Interesting.
So I had to kind of explain it.
So it wasn't Kevin that was the
No,
leader?
it was a lady on Saturday. I don't remember her name.
Oh, okay. I thought Kevin was doing both of them.
I think you joined the wrong workshop.
Really?
Yeah.
Were you there?
Yeah.
Weird.
There was just two of us there.
Oh, well, I must have joined the wrong one. I just joined the link that was there. She did say, oh, you seem farther along than everyone else.
Oh, maybe you were in a 980 workshop or something. But
maybe. I mean, I got the help I needed.
That's good. I'm sure they're, you know, the instructors there that are doing it definitely could help at whatever level you're at, but that's,
There was only
yeah.
2 of us there. Oops.
No, I mean, I know. I'm glad you guys are going into those workshops though, because, you know, they're there for you guys to get the extra help and just kind of see. Sometimes it's like, I have some questions, but then sometimes hearing other people's questions there can also help. You're like, oh, I didn't think of that. And then you can help get things clarified that way too. So that's...
My problem is sometimes I don't know what questions I have.
Yeah, and you're not alone on that. I know a lot of people are kind of like, you know, they're feeling like, I'm so confused. I'm not even sure what questions to ask. Or it's just like, until you start working through a problem, you're like, okay, this is where I'm getting stuck, but I don't know how to explain it in words, like where I'm at, right?
Yeah.
So, yeah, so I love those workshops because you can get so much one-on-one help there. So if you guys haven't tried them out, please, please, please try them out because they are great. And they're talking like they might be getting rid of some of the workshops in the fall if they're not better attended, in which I'm like, no, students need these workshops. So please, please, please try and go to them if you can, if you need some extra help. They're so good. So, all right. Were there any questions on the completing the square that you had that you wanted to look at specifically? So that was in 7.1. Was there anybody that had homework questions that they wanted to look at there? All right, well, let's look at one then kind of like this. And I want you guys to try and see what you can do with this one. All right, so again, you're going to solve by completing the square. And so we're going to have x squared minus 2x, minus 2x minus 5 equals 0. Okay, so again, I want you to solve using completing the square. So maybe go back up, look and see what we did on the last one, and try and see if you can figure out how to solve this doing completing the square. Because just like Amber was saying, sometimes you got to work through it to see maybe where you have questions. So let me give you a few minutes to just try and work it. Okay, let's take a look at this. See where you guys got to. So notice that the first thing I did is I started by adding that constant term over to the other side. right? And so then on the next step, I put in my blanks that I'm going to need to fill in, right, with that completing the square part. Okay, so can somebody tell me what number is going to go inside my blanks here? How do we figure that out?
It's 1.
Okay, positive 1. How did you get that? Yep, so take half. It looks like people are saying, okay, they're taking half of the middle term. All right, so half of the middle term is negative 1. And then you have to square that whole thing. All right, so negative 1 all squared is just positive 1. And so that's the number that you're going to be adding to both sides. And you are going to be adding it to both sides. Okay. And then now we can factor this. All right, and remember this will factor, and you don't have to take this step always here, but I just want to help to make sure everybody is seeing what we're doing. If we're trying to factor this x squared minus 2x plus 1 on that, right, we're going to have it's going to be x minus 1 times x minus 1. And notice that this number, right, that half, right, of our middle term is that number, that negative 1, right? And that's always going to be the case. And so really we can write that as x minus 1 quantity squared, right? That whole thing squared equals 6. Okay, then what do we do from here?
Take the square root.
Yeah, right? We're thinking, okay, how do I undo squaring something? Because I'm trying to get this x, right, out of there. So I need to do that. So if I square root both sides, I'm left with x minus 1 on the left, and then plus or minus the square root of 6, right, on the other side. So sometimes you'll be left with some irrational numbers, and we'll just keep those in square root form. And we know they're irrational because 6 isn't a perfect square, right? It doesn't come out to be a whole number answer when we take the square root of it. That's okay, right? And then remember, we can write these down as two separate things. So x minus 1 equals the positive square root of 6, and x minus 1 equals the negative square root of 6. And so then to get x alone, we're going to be adding 1 over. And when you're adding that 1 over, you should write it in the form of, so put the number first. So we're going to put 1 plus the square root of 6. It's not wrong if you put square root of 6 plus 1, but sometimes, when students don't put it in the front, they make a mistake with which number that has the negative. So we'll just put, and on this one, positive 1 minus the square root of 6. Okay, I mean, you could write it as negative square root of 6 plus 1. It's the same thing, but sometimes it's just better to write it that way. Okay, and then it'll always be asking for your answers just separated by a comma in there. So you should most of the time end up with 2 answers. Sometimes you'll end up with 1 answer. We'll talk about why that is the case as we're kind of going along here too. But do you have questions about this one? How we got there? All right, well, let's move on then to 7.2. 7.2 is always a fun section that a lot of people tend to like. And this is talking about the quadratic formula. And a lot of people have heard the quadratic formula before. All right, and that's where so remember, you're going to be using, write this down. So here's a quadratic equation. All right, and going along with that quadratic formula, we can use this formula that says Oh, you want to hear the song? Well, you are in luck. I am going to sing it for you. And it sounds like Angelina's going to join me. I'm just kidding. You don't have to. But I will sing it for you because, and you might have a different tune to it. Who knows? But it is a good way to make sure that you remember it, right? So that you have it in your mind. So it goes x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Is that the same one that you learned? Yes. Okay. It is awesome. Just sometimes having a tune to it, being able to, remember this, because this is a crazy looking formula, right? And so just sometimes having a little song, a little tune to go along with it can really help. All right. And so notice that the A, B, and C that I have in my quadratic equation, right, are the same A, B, and C that I'll be using down here. So maybe I should have written them as like lowercase letters so they looked exactly the same. But yeah, but it's, so those coefficients, right, are what we're going to be using to substitute there in place of those. So this is just another way that we can solve these to figure out what x is, right? So when we're using the quadratic formula, you just need to make sure that just like when it was with factoring, that everything is over on one side and the other side is equal to 0. And if it's not in that form, then you need to get it in that form before you decide what your A, B, and C are. Okay? So let's look at, let's see. Where did that example go? All right, so let's just try this one. So we're going to solve, right, specifically using the quadratic formula on this. And we're given, let's see, to do this one. So x squared plus 5x equals 4x minus 2. Okay, so this is where it starts, right? And so we need to get it so that everything's over on one side, the other side's equal to 0. So we can figure out what our A, B, and C are on this. Okay. So when we do that, let's subtract our 4x over. So that's going to give us x squared plus x. Right, and then we're going to add the 2 over also. We can do this at the same time, or if that looks a little messy, but we're just moving everything over. All right, and so then on this, right, we got, so some of our coefficients look like they're missing, but remember, all right, there's always a 1 in front of there. So we're going to have A equals 1. All right, we've got B equals 1 also. That doesn't happen all the time where those are the same. And then C equals 2. Okay. All right. So again, we'll go through that quadratic formula little song again, right? But remember, this is recorded, so if you guys want to go back and listen to that part again, you can, just to make sure that you kind of get that down, right? But again, it goes x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Right, so it's like to the tune of Pop Goes the Weasel, I think. So, right, and so then when we put these, so now we have this, so x equals negative 1, right, plus or minus square root of 1 squared minus 4 times 1 times 2 all over 2 times 1. Right, so I'm just putting those numbers in. Wasn't that beautiful? I mean, you know, that, my singing, you guys are just so lucky to have, you know, just a beautiful singer that I am. Oh, all right. So, and then all we have to do here is just simplify what we have, right? And so notice that we have this plus or minus in here because that's what's going to give us our two different answers, because we notice it is a quadratic, so we are expecting two answers, right? So let's go ahead and simplify this up now, right? So first need to figure out like everything inside the square root. Let's get that all together. So 1 squared is just 1 minus 4 times 1 times 2. So all of those multiplied together would be -8. Right? And then all over positive 2. All right? Now let's keep simplifying here. So x equals -1 plus or minus the square root of -7 all over 2. Uh-oh. Okay, so we got a negative inside a square root. What do we have going on here?
We can take it out with an I.
Yes, right? Remember we said at the end of the last module, we talked about these complex numbers, these imaginary numbers. So if we have a negative under the square root, we need to simplify that so it's not there. We need to simplify it in terms of I. Now, let me show you, like on your homework, right? You could simplify this in one of two ways. Let me kind of move this down. So we could say x equals -1 plus or minus. I always like to put the I out in front of the square root, because otherwise, sometimes if you put it behind it, just be really careful, because on the homework, if you extend that over and the I is inside that square root, it's going to mark it wrong for you, right? So you have to make sure that if you're putting it on the other side, you got to have like a space there in between it so that it's the square root of 7 times I. We don't want that I underneath the square root. So to mitigate that, to make sure that doesn't happen, I always like putting it out in front, and it'll accept it that way just fine. And then you can have it over 2. The other way that you can have your answer written is when we talked about that A plus BI form, right? Where you're basically dividing both of these by 2. So you could say -1 over 2, right? Plus or minus I square root of 7 over 2, right? But remember, there's not a plus or minus sign on there, so you'll have to write those out separately, right? Two different answers there. But whether you have it as, all being divided by 2 or splitting that up, it'll accept that answer either way. Right, and it will accept the answer if you put the I after the square root or if it's in front of the square root. Okay. Are there questions on that? Did anybody have any issues with that when they were trying to get those answers put in on homework? So any suggestions that you might have could be really helpful to other students that haven't done it. All right, so you will encounter some imaginary solutions, right, on this, and that's okay. We're going to talk about in 7.3 a little bit why we come up with these imaginary solutions sometimes when we're solving these quadratic equations. Okay. All right, well, let's go ahead and just try one other. I'm going to have you guys work on this. I want you to use the quadratic formula to solve this next one. So we're going to do x squared plus 11 equals 6x. I lost my place where I was at there. All right, so go ahead, use that quadratic formula to solve that. Okay, let's just look and see if you guys got this. So make sure that you remember that you needed to subtract the 6x over first, right? You can't figure out what your a, b, and c are until everything's over on one side, the other side's equal to 0. And so our a is 1, our b is -6, and our c is 11. So when we're putting this in, remember we're doing x equals -b, so the opposite of b. So since b was negative before, make sure you have this in as a +6, right? Because we have to do the opposite of that. So plus or minus the square root. So that -6, put it in parentheses and square it because you're squaring that whole thing. So be really careful when your b is negative. There's a few things you need to watch out for there, right? And then -4 times a, which is 1, and c, which is 11, all over 2 times 1. All right, so first of all, any questions about how I put that in? Okay, then from here, right, let's keep going and see what we have. So this -6 all squared is really +36, right? And then when I multiply those together, we're going to have -44 all over 2. Right, so I keep going. Let's simplify this more. 6 plus or minus the square root of -8 all over 2. Right, and then we can simplify, make sure that we simplify that radical more here. So let's make sure that on this next step that you're with me here. So 6 plus or minus, well, we see that there's a negative, so we know an I is going to come out. But we also, right, with the 8, if we do the factor tree on it, right, it's 2 times 2 times 2. So a 2 gets to come out as well as an I, right? So 2I comes out, leaving that 2, that other 2 stuck inside, right? And then I could write this down as, all over 2, or I could write it just these individually. And I'm going to write it individually so you can see that if you write it individually, it actually has some good benefits to it, because then it's easier to see if it's all the way simplified. So here, 6 divided by 2 is 3, right? Let me see here. 2 divides into 6 3 times, and then 2, and that 2 on the outside can also divide out. All right, so that just leaves me with plus or minus I square root of 2. All right, so there are my two solutions. So 3 plus I square root of 2 and 3 minus I square root of 2. What can I clarify there on that one? Will you raise your hand for me? Press the hand raise button if you were able to get to that. Let me just see how everybody's doing there. Okay, if you didn't get there, can you tell me maybe, like what you did? Because I'm sure you're not alone. Let's figure out what some of these common mistakes are, so don't do it going forward. You didn't break it down? You mean at the end? Like simplify it? Okay, yeah. And that's really an easy thing, to not do. And I'm actually unsure if you left it unsimplified, like, back up here. Does anybody know? Did you try and put something like this in as your answer? Did it accept it?
It won't.
Okay, it'll tell you need to simplify it. So yeah, so just make sure that you kind of, break it down like this, get it into that simplified form, because I think it even says something in the directions to simplify your answers. Okay. All right, well, let's take a little 5-minute break and give you guys a little brain break for a few minutes, and then we'll come back and we'll talk about the 7.3, and if there are any specific questions off of 7.2, we can look at those before we move on to 7.3. But let's go ahead and take a little 5-minute break, okay? All right, so in 7.3, we're going to be talking about something called the discriminant. Okay, and this is part of the quadratic formula that actually tells us a lot about that, certain quadratic equation that we're looking at. And so it's a really good thing to know about. And basically the discriminant is telling you how many solutions there are. And what kind. Of solutions. It doesn't actually give you the exact answer, but sometimes, and you'll find that when you are like in 1050, sometimes you don't care about what the actual solution is. You just want to know how many and what kind they are. And that's going to be good enough for you. And it takes a lot less time to do that, to use the discriminant to figure this out rather than solving it all the way down. Okay, so let's look at a few things with the discriminant. So remember that the quadratic formula says, I'll sing it one more time for you, all right, because I heard you guys wanted an encore, so here we go. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right, so there is our quadratic formula. The discriminant is the stuff under that square root, right? So just this b squared minus 4ac part of it, right, is what we're kind of talking about with the discriminant. So there's 3 different things that can happen. And so let's talk about what kind of solutions we might end up with. So when we have the b squared minus 4ac, right, is greater than 0, meaning it's positive, right, we get a positive answer. All right, then you're going to end up with 2 solutions. And these solutions, we'll talk about them a little bit more, they're going to be 2 real solutions. Okay, so when it's greater than 0, when the answer that you come up with, when you figure out just that discriminant part is positive, it's bigger than 0, then you're going to have 2 real solutions. Okay, and they could be rational, right? So let me see how I want to write this down here. So we could have rational, or you could have irrational. Okay? And if they're rational solutions, that means that the number that you got, this positive number that you came up with, was a perfect square. Okay? So, oops, spelling perfect wrong. How imperfect is that, right? Okay, it is a perfect square, but it would be irrational if it is not a perfect square. And we'll talk about some examples of these too. But Okay, so that's one thing that can happen here with it, right? Is we could have some positive, like our answer comes out to be positive. Now, I want to make a connection here next to why are these, why do we get two real solutions? What is happening? Like when I graph the certain, quadratic equation I'm talking about, so here, I could have like some kind of a right side up parabola, right? And it's crossing, actually let me put that in a different color. It's crossing the x-axis at two places. And these are the solutions, right, where it's crossing. You could also have an upside down parabola, right? And you would still have two solutions. Okay, so maybe something that I want to also talk about here is you'll hear the words. I want to make sure that you understand these are talking about the same thing. So if you hear, like zeros, roots, or x-intercepts, whoops. Those are all talking about the same thing, where that parabola is crossing the x-axis, right? Here's my x-axis, and I'm getting two different solutions. That's where it's crossing, okay? And so when I have a positive one, that's what's going to happen, okay? That it's going to end up being two solutions because it's something like this. All right, something else that could happen. So I'll do a little squiggly line down here so we can see that this is a different case. So what if that discriminant, that b squared minus 4ac, ends up being negative, if it's less than 0? All right, so if that's negative, right, so if it comes out to be negative, then that means that we have no real solutions, and they're actually going to be imaginary solutions. So we're going to get two imaginary solutions, right? And think about why that would be, right? If we're looking back up here at our quadratic formula, right, this b squared minus 4ac is what's under the square root. So if it's negative, then we know we're going to get imaginary solutions, right? So that is important to know here, right? But then some people are like, well, what does that mean? Like with a graph, like how does that, relate? How do I relate that to what's going on with a graph? Well, what we have going on this, if they're imaginary solutions, then they're parabolas that are just kind of floating. They never cross that x-axis, right? So they're either like, right side up parabola floating above the x-axis, or they could be an upside down parabola that's floating below the x-axis, right? So by floating, I mean they don't have any roots, right? They're not crossing that x-axis anywhere. So if we were to graph it, that's kind of what's happening with this. Okay. All right. And so that's one of the, and then one other thing that could happen, right, is we could have the discriminant, so the b squared minus 4ac, right? So that part, what if it equals 0? Right? Well, when it equals 0, that means that there's going to be one solution. So let me write down here. So down here, so if it equals 0, you're going to have one, and I'm going to put it down this way as one repeated solution, and I'll show you why. All right, so if it's 0, if it comes out to be 0, then you're going to have one repeated solution. Right? And basically what's happening on this, if we were to graph it, all right, think about it's saying, remember our solutions are where they're hitting the x-axis. So it's like a parabola that hits the x-axis and then bounces back up. Right? So it's only going to be there, right, at that one point. And that also would work. It doesn't matter. It could be upside down as well, right, and still have something like that happening. Whoops, why did I do that? Went up too far. Okay, and so, and you'll kind of see, right, if this comes out to be 0, we'll do an example here in just a second so you can see what happens here on it and why, you know, when we're talking about this one repeated solution, kind of maybe what I mean a little bit more by that. Okay, but these are the things that you need to know about the discriminant. Right? Remember, it's telling you how many and what kind of solutions, right? Are they imaginary? Are they real? Right? If they're real, are they rational or irrational? Right? So you can tell a lot about the discriminant. Okay? All right, let's look at some of these. So if I have, let's try like this. So here is first example. Whoops. So I want you to determine what type and what kind of solutions, right, is what you're doing on this. So use the discriminant to determine what type and how many solutions. Okay, so for this first one, let's look at this equation. So 2x squared plus 7x minus 3 equals 0. Okay, so remember, you're not going to put it all, you don't need to use the whole quadratic formula. You're just going to use the part of the b squared minus 4ac. Okay, and still use those the same way we did before. We got our a coefficient, our b coefficient, and our c coefficient. All right, so when I put those in here, so my b is 7, so I got 7 squared minus 4 times positive 2 times negative 3. And then we're just going to go ahead and simplify that up. All right, so I get 49, and then we got a negative times a negative, so I know I'm going to end up with a positive here. And then I've got 4 times 2 is 8, 8 times 3 is 24. So I've got 49 plus 24, which is 73. Okay, so this 73 is not the answer that I'm going to be given. Remember that 73 is telling me, right, it's cluing me in to what kind and how many solutions I have. So what do you guys think? Somebody either unmute yourself or type in, what type and how many solutions do we have on this?
It's positive, so we would have 2 solutions, and it's not a perfect square, so it'd be irrational?
Yeah, perfect. So we've got 2 irrational solutions, and that would be your answer, right? But that's what that 73 is telling you, right? It's telling you, just in the way that she was saying it. I liked that, to help you figure out that you got those 2 irrational solutions. Okay, let's do just a couple more here, and I'm going to have you guys just do these on your own, right? So let's do So let's do x squared plus 5x plus 8 equals 0. And then let's also do another one as 9x squared minus 12x plus 4 equals 0. Okay, so go ahead and use the discriminant on those two and see what type and how many solutions we'll end up with. Or something, so it's a little bit easier to, so put it into the chat what it was the numerical answer, like we came up with 73 on this one. What numerical answer did you come up with? So it was -7. Let's just double check and make sure everybody is good on that, right? So we'll do, when we do b squared minus 4ac, our b is 5. So 5 squared minus 4 times 1 times 8. So I get 25 minus 32, and that will give me -7, right? So what does that mean of what kind of solutions and how many are we going to have? Okay, awesome. Okay. So complex irrational solutions, right? And because if it was a perfect square on this, it would be a complex rational solution, right? So I'm glad you said it that way, because there's definitely some things that you could, notice on that too, how to put that down. But yeah, so I just kind of said 2 imaginary solutions, but 2 complex irrational would be definitely more complete. Awesome. Okay, and then what about, call this other one over here, part C, maybe. All right, so what numerical answer did you come up with on part C? So go ahead and type that into your chat. And then 3, 2, 1, hit enter. Everybody come up with 0? Okay, and so when you have 0 there, right, that means that you're just going to end up with 1 real solution, right, on that one. So I want to have you, think about this too. And if we were to, I'm just going to take this and do something different with it rather than looking at the discriminant. You guys already did that. But what if you factored this, right? I want to kind of show you what happens here. This would factor to be, well, that's a perfect square, so 3x and 3x, and then 2 and 2, right? And then both of those need to be negative. So do you see that that if we were to try and, figure out the answer to this, right, we get that same factor. That's why I say it's 1 repeated solution, right? 1 real solution here, because you get x equals 2/3, on both of those, but it's still the same answer. And that's always what happens on those type when the discriminant is 0. So we have the same number, or the same factor, right, there on each of those. So hopefully that was a little bit helpful there. Questions about the discriminant? All right, well, let's look at one other thing that I wanted to look at on 7.3 was they asked you to write equations when they give you the solution. So it's kind of like working things a little bit backwards, right? So if it says, let me put this one down here. So find an equation given the solutions, and then they'll give you two solutions because we're dealing with quadratics. When again in 1050 you'll kind of be doing this again, but they'll give you like 4 solutions and you'll figure out what the equation would be, or 3 solutions and give you that, right? But for right now we're just sticking with 2. So what if they tell us that x equals 3 and x equals -2/5? Okay, so we're trying to work backwards on this. Can somebody just unmute yourself and tell me how would we go about finding the equation if we know the 2 solutions? What should we do here?
Set them equal to 0.
Does anybody have an idea?
You would subtract the 3 and get it to be x minus 3
Why don't we
equals
start
0.
by moving this over to the other side? So remember when we let's go back up here to this one. Remember, if I took this 3x minus 2 and put it equal to 0, right? And then I solve it, and I get x equals 2/3. Well, I'm just working backwards from here, right? It's giving me this solution, and I'm trying to work the other direction with it to figure out what that factor would be. So, I mean, really what you're doing is, on here we're like, okay, I'm going to subtract 3 over to the other side. So I'm getting it over to one side and equal to 0, right? So I get x minus 3 equals 0. And then I'll add the 2/5 over. So that's going to give me x plus 2/5 equals 0. And then those are my 2 factors. And then I just need so I have the x minus 3 in one parenthesis and the x plus 2/5 in the other parenthesis. And then from here, I just really need to FOIL those together. Oh, I have people muted? Or am I muted? Let's see what happened here. I don't know why it is going so crazy. Let me look and see. Did not want to mute everybody. All right, Jordan, will you try and say something again?
Hello?
Okay, yes, I can. Yeah, I don't know. I'm wearing these headphones today, and I think they're giving me some issues. So, keep hitting a weird button somewhere. Okay. Well, good, because I just thought you guys were ignoring me, so that's good to know. You guys are trying to talk to me. All right, so then we'll start from here, right, and put this, both factors equal to 0, and then you're just going to FOIL those out. And, sometimes you'll have some fractions on there, but that's fine. You can work with those fractions. So let's go ahead and try and FOIL these through, right? So x times x gives me x squared. X times 2/5 gives me 2/5 x. And then -3 times x, -3x, and then -3 times 2/5, right? Remember, if you put the 1 at the bottom of the -3, all right, so you have a fraction, then you're just multiplying across the top, multiplying across the bottom. So that will give you -6/5. All right, and this all equals 0. Okay, but then you're not going to leave your answer in this form because you have these fractions. So the next thing that you're going to want to do is clear these fractions by multiplying by the LCD, like we've talked about. And we can see our denominator on this is just 5, right? Some of them have 1s on the bottom, some have 5s on the bottom. So let's take and multiply the whole thing by 5. Right? So that's going to give us 5x squared. And then on this next one, right, 5 times 2/5 x, right, if I do that over here, 5 over 1 times 2/5, right, those 5's divide out and I'm just left with that 2x. All right, and then 5 times negative 3x gives me a negative 15x. And then I can do the same thing. Right, the 5's are dividing out, leaving me negative 6. And now I just need to get my like terms together, and I will have my answer. Right, so 5x squared, get my middle terms together, minus 13x minus 6 equals 0. And so that would be my answer. And if I went, the other direction and I tried to factor it, you'd see that it would factor out to what I have in green there, right? The x minus 3 times x plus 2/5. Right? So it's kind of, well, it might look a little bit different because you'd have the 5, you'd probably have 5x plus 2 instead, because they usually don't have that 2/5 there. But either way, there's kind of, you can kind of see the undoing of it, right? Whenever there's a way to do something in math, there's always a way to undo it. Okay, what questions can I answer there, or do you have any comments about it as you were working through your homework or just some of the videos? Okay, let's take a look at another one then, because there's some that look kind of crazy. And I want to make sure that we talk about these other ones that look a little bit weird. Okay, so same directions, right? But this time we're given our solutions. Our x equals 2 minus 7i and x equals 2 plus 7i. All right, so we've got some imaginary solutions this time, these complex solutions, and we can still do the same thing that we were doing above. And so if it gets confusing to you on how you need to write them in the parentheses, right, in the factored form, remember you're just subtracting everything over to one side to get the other side equal to 0. Right, so when I do that on this first one, right, I'm subtracting 2 over, but then I'm also adding 7i. Right, so that those are gone on that side, and then I'm left with, now I can't combine that x with anything, so I know this looks kind of weird, but it's going to be x minus 2 plus 7i. Right, and that equals 0. So I'm just moving everything over. Okay, so that's going to be one of my parentheses. I'm like, well, that looks really weird, Becky, and it does, okay, but we can deal with it, okay, so don't get freaked out. And then on the other one, same thing, we're going to subtract the 2 over and subtract the 7i over. And so that means I'm going to have x minus 2 minus 7i equals 0. And so my other parenthesis is x minus 2 minus 7i. Okay, so let me make sure everybody's good to there, because sometimes this is the part where a lot of people get confused with these imaginary or these complex solutions, like how do I need to write these in the factored form? Are there questions there? Okay, so then you're just going to multiply these together, and even though, I mean, it's kind of like FOIL, it's not quite because we have 3 terms in one and 3 terms in the other, but it's still the same idea, right? We're going to take the x and multiply it by the x to give me x squared. Then I'll take the x and multiply it by the -2, give me -2x. And then x times -7i is going to be -7xi. All right, so all I did was multiply the x through the second set of parentheses. Now let's take the -2 and go ahead and distribute it through. So -2 times x is -2x. -2 times -2 is +4. And -2 times -7i is going to be a +14i. All right, and now I still haven't distributed my 7i, so I need to do that now. So 7i times x is going to give me a +7xi. And then 7i times -2 is -14i. And then the last one there is going to be -49i squared. All right, and this all equals 0. All right, remember equaling 0 is part of it because that tells us it's an equation. So don't forget about having that equal 0 part there. And now I need to get, just get my like terms together, and a lot of things end up canceling each other out here, which makes it nice, right? I see this -7xi and this +7xi. I see my 14i and my -14i. All right, and then remember, I squared is the same thing as -1. So I'm really saying -49 times -1. So this really is going to simplify to be a +49 there. All right, and so let's go ahead and see what we have here now. So I've got x squared, and then I've got my -2x and another -2x, so -4x. And then I've got +4 and +49, so that's going to give me +53 equals 0. And then that would be my answer. That is the equation that has these 2 solutions to it. All right, help me see where I can help you on this more. Is that crazy? Is that making sense? Maybe just let's type in the chat on a scale from 1 to 5, right? Let's type this in. So 1 being that you are not understanding it very well, and 5 being I understand it like almost perfectly. Go ahead and type in the chat where you think you're at on these type. Good. Yeah, I love these quadratic. I love this module on quadratics. I think they're a lot of fun, but some people are like, "Oh, Becky, you're so silly." It's still math, but it's still fun. Okay. All right. So let's try. So this kind of the same idea that we did on this last example. I want to see how you can use it to help you figure out this next one. Okay, so this time we have the same directions here where it wants you to write a quadratic equation given the solutions. Okay, so write a quadratic equation given the solutions. And the 2 solutions they're giving you this time is x equals 3 minus the square root of 14 and x equals 3 plus the square root of 14. Okay, so I want you to, let me give you a few minutes. I want you to try figuring out how would you write that quadratic equation if you know those two solutions. Okay, hopefully, let's see here. All right, so hopefully this is what you came up with before you started multiplying those out. All right, and so I'll just kind of quickly go through and just distribute each of these through. Okay, so this is what I came up with, but notice on this last term here, I want to make sure it's clear, you're not squaring, like it's not the negative square root of 14. That whole thing isn't all squared, it's just the square root of 14, right? So you're still going to have minus whatever that number is. So be really careful with that. Make sure you're noticing the difference between that. You're just taking the square root of 14 and squaring that. Okay, and then we see again there's a lot of things that end up canceling out. So I'll get rid of those. All right, and then what we're left with is x squared minus 6x. And then so this here, right, is remember when you have the square root of something squared, right, that just leaves that number inside there. So this is really going to be minus 14. So I've got my 9, right, minus 14 is going to give me negative 5. So this should be what you guys came up with. Hey, raise your hands if that's what you got for your answer there. Let me see how you guys are doing. Amazing. You guys are so awesome. Okay, and if you didn't get there, that's fine. Look and see what you did, right? Was it a mistake with this last one? Did you accidentally put that down as plus 14 and then you added that with the 9 and that gave you a different number there, right? Just make yourself a note out to the side if you missed something there so that when you do it on the homework, you know, you're going to be practicing that correctly, and so that way you'll, you know, when the quiz comes and stuff, you'll be able to do that. Okay. All right. Other questions that you guys, any questions on the homework from 7.3? Anybody? Okay, now some of you haven't gotten there, and that's fine. I know it's hard. There's, you know, like when there's 3 sections, you know, trying to get through all of that, but hopefully this is making some good sense for you. Okay. All right, so I want you to try, I'm gonna do a couple of questions here. So this is kind of like the mixed up thing. It's sometimes easier in the homework where it's just like, okay, I know all of these they're telling me I need to do by complete the square. On this homework, they're telling me I'm going to use the quadratic formula, right? But when you're given like a quiz situation and it's not telling you how to solve it and you've got to pick which way you're going to do this, then I want you to kind of practice being able to do that, okay? So on these problems, I want you to first, decide which method would be easiest to use. And that's going to be a little bit subjective, right? Some people find, one way easier to use than the other way. So remember that the methods that we're talking about here are factoring, where we're using that zero property rule, or we could use the square root property rule. Right, or there's the completing the square, and then the quadratic formula. So those are the 4 different ways that we've talked about so far. So I first want you to decide which of these methods you think looks easiest or best for you to use to solve the quadratic, okay? And then I want you to solve it, okay? So then solve using that method. Okay, and I want you also to think about, like, why, did you think that, that method would be the best to do? Okay, so on these next questions here that I'm going to write down, I want you to do these 2 things on there. Okay, so here are your questions. So I want you to do, let's see. Whoops. All right, so there's part A. Part B. I'm going to try this one. Part C. And part D. Let's try. Okay, so go ahead. All right, you're solving on all of these. All right, and so first go through and decide which method you think looks easiest to use to solve it. A good way to go about it. Now, one thing that we didn't talk about is with completing a square, right? We only talked about when our leading coefficient was 1. And so to try and do completing the square on this, our leading coefficient wasn't 1. And so you're actually going to talk more about that in 1050, what you do with that. So that's why completing the square wouldn't be a good one for this one necessarily. I mean, once you factor out that 9, then, you could do that, but it's still that 9, you have to figure that 9 into it. You can't just factor the 9 out and then complete the square on the other part. That 9 still has to be a part of it. So that one could be a little bit trickier to do that way, since we haven't talked about that. Okay, what about part C? So yeah, I think the quadratic on this one would be the easiest. If you look to try and factor this, that's going to be, it's not going to end up factoring for one thing, but, looking at it, it doesn't look like it's very easy. It's not like there's a, greatest common factor of 4 or something that we could take out of it like we could in part B. So I agree. I think the quadratic formula would be the best one to use here. Why not completing the square?
The leading term is a 4.
Yeah, that leading term's a 4, and so we haven't talked about how to deal with that. So quadratic formula would be best there because of that. And then on part D, what do you think here? I mean, does that factor, first of all, what times what is 11 that adds to be 8? It doesn't, right? So factoring definitely is not going to be a good way to go on this one, right? So what do you think here? I think maybe completing the square. I know some people are like, oh, I don't really like completing the square. But I think when the leading coefficient is 1 and you have something like this, I think it's a good way to go. I think it can be really good. And you're going to find that we're going to talk about in Module 8 that there's other reasons why we need to know how to complete the square besides quadratics, and that will come into play, and you'll have to use it then. So please practice using completing the square so that when we get to that part, you'll know what to do. But I also think that the quadratic formula would be good too. If you are thinking, well, I don't really want to complete the square, and these numbers are pretty small, it looks like it might be good to do the quadratic formula, right? So the quadratic formula oftentimes is what a lot of students choose because you can see that it can be used in several different types of quadratics. The only one that it's not really good for is if it's already, like part A where we have something all squared. But in the other ones, you could definitely use that. Okay. There are questions on that? Do you see why and how to kind of pick which one is going to work when? So I want you to, try these 4. I know we're kind of out of time here, but I want you to try those 4 and make sure that you know how to solve those, doing, the way that you picked specifically on these, and make sure you understand why those are, when it's good time to use which type, right, of method to solve these. Okay.